Hello guys, in this video I will talk about multi-threading concept in the Java, like why we have multi-threading, how it works, what are the method of multi-threading, how multi-threading is useful, and how we can make our code thread safe. So we will try to understand each and every topic one by one, right? First we will start with the basic concept of multi-threading. Now we need to understand what is multi-threading, right? So multi-threading in Java is a process of executing multiple threads simultaneously. What does mean by that? The meaning of this line is, let's say when you have a task, let's say you have a task A and you want that task to be done by multiple people, right? So how do you do? In Java, you have a facility of multi-threading, which means all your 10 persons will do the same work same time, right? Which is possible in case of Java, and that is possible by the use of multi-threading concept, right? And thread is basically it's a lightweight sub process. It's a smaller unit of processing. Multi-processing and multi-threading both are used to achieve multitasking, right? So if somebody will ask you how you can achieve multitask, like how all people can do same task, so that can be achieved by multi-processing and by multi-threading, right? And thread is always a lightweight process. So what happens is when you create a multiple thread of a class, right? In that case, all the thread will share the same memory area. Okay, if you create 10 thread, that does not mean that on all 10 thread requires different memory area. No, all thread will share the common area which is given by thread scheduler to the thread. Now we use multi-threading always than multi-processing because threads share a common memory area. Okay, so we always prefer multi-threading compared to multi-processing, because in multi-threading all the threads will share the common area, right? So let's say you have a area in the heap memory, right? Let's say you have a big area in the heap memory, and one part of area, let's say, which is assigned by thread scheduler to your class thread. Now if you make 10 thread, that a smaller area will be used by all 10 threads. It will not acquire 10 smaller area in the heap memory, no, right? So that is the benefit of multi-threading. Now JVM will not allocate separate area for all the threads, so it will save the memory, and switching the context between two thread are very easy. Okay, so one thread can switch context to the other thread. So let's say 5 threads are running, right? So when thread runs, basically it requires a memory to run, and that is provided by the thread scheduler. So since every thread is using the same common area, switching off one thread area to other thread area is very easy. Okay, that is the reason we go for multi-threading than multi-processing. Advantage of Java multi-threading: what are the advantage we have? You can perform many operations together, right? Lot of operations you can do that together, so actually it saves times because you are running parallel things. So you are running multiple things parallelly, so you can save the time. It does not block the user because thread are independent and you can perform multi operations at the same time. So let's say 10 user can do same work, right? Because it's a multi-threaded code, so 10 user can work on the same time and it will not block any user. Thread are independent, so it does not affect other threads if exception occur in a single thread. So let's say there are 10 threads, okay, and 9 thread is going fine, but there is a problem with the 10th thread. So that 10th thread will not create problem for other 9 thread. That is the benefit of multi-threading. Now what is multitasking? So multitasking is the process of executing multiple tasks simultaneously, right? Here you are trying to execute multiple tasks. We use multitasking to utilize the CPU. Okay, there are two ways we can achieve the multitasking: by multi-processing and by multi-threading. So if somebody will ask you what does mean by multitasking, just say that it's a process of executing multiple tasks simultaneously, right? So you have, let's say, 10 tasks and you are doing all the 10 tasks same time, right? That we call it as a multitasking. And this multitasking, what happens is, the main benefit is you actually utilize the CPU, And there are two ways you can achieve the multitasking: by multiprocessing and by multithreading. So through multithreading, of course, you can achieve multitasking, and even by multiprocessing you can achieve the multitaskings. Now we need to understand multiprocessing. So multiprocessing basically it's a heavyweight process. It's not a lightweight process. Okay, it's a heavyweight. Each process have its own address. That is the problem. See, each process when you run, right, it has own address in the memory, and each process allocates separate memory area. That is the problem with multiprocessing. Like, let's say you have 10 tasks to be done. All the 10 tasks will get a separate area in the memory. So assume that you have a big house. In big house you have one room. Let's say you have 5 rooms. Now if you have 5 tasks and you want to do through multiprocessing, all your 5 rooms will get occupied, right? But if you go for multi-threading, you can assign one room. That one room, all the thread will use that one room and your task will be done. Now the cost of communications between process is high. Why? Because each process has a different memory, so communication is high. Like, let's say you are in 5 different rooms, right? So to communicate in each room, you need to go to the room and you need to communicate. So the cost of communication is high. Switching from one process to another requires some time for saving, loading register, memory maps, updating list, and etc. So it's like, when you try to switch from one process to other process, it requires some time, because you need to save that previous data, you need to register again, you need to see the memory maps, like where other process is running. So you have to see the map in the memory up, and you need to update the list. Like thread scheduler has to update the list, like where this process is going now. So these are the actually challenge you have in case of multiprocessing. But in case of multi-threading, all the threads share the same address space. Thread is always lightweight, and the cost of communication between thread is very low, because it shares the common area, right? So switching the context between one thread to other thread is very easy, because all thread utilizes the same area, right? So that's where, this is the reason we prefer always multi-threading. Now we need to understand what is thread. So thread is a lightweight sub-process basically. It's a smaller unit of processing. Threads are independent, which means if exception occur in one thread, it will not impact other thread. Okay, it's a lightweight process. It's a smaller unit of processing. It uses same common area of the threads. Threads are independent, which means if there is any problem with one thread, it will not interrupt the second thread. So thread has a life cycle. Every thread has a life cycle, and this life cycle of thread in Java is controlled by JVM. So the life cycle of thread in Java mainly is controlled by JVM. The Java thread states are as follows. So every thread has a life cycle called new, runnable, running, non-runnable. Let's say if thread is blocked, we call it as a non-runnable, and terminated. This is the cycle of the any thread: new, runnable, running, non-runnable, and terminated. Now what does mean by new? So the thread is in new state if you create the instance of thread class. So let's say, to make any class as a thread class, your class has to extend the thread class, right? And you create an instance of the class. So before calling the start method, whatever state we have, we call it as a new. Then runnable, the thread is in runnable state after invocation of a start. So the moment we call the start method on the reference of the class, right, the start method will call the run method, which we'll see by the example going forward. Here we'll try to understand. So there are two methods: one is run method, one is a start method. And the start method will always call the run method. So when we call the start method, that actually the situations or the current situations of the thread will be runnable, right? So the moment you will invoke the start method, the state will be runnable, but the thread scheduler has not selected it to be running thread. Okay, so you just invoked the start method, but thread scheduler has not selected it to be running thread. We call it as a runnable. So you just call the start method, but thread scheduler basically decides when it has to be run. So in the thread, everything is taken care by the thread scheduler. Thread scheduler, you can say that it is a guide which will guide all the thread when it has to be run, when it has to be paused, when it has to be rerun, or everything is done by thread scheduler. Okay. Now what is the running state? Running state means a thread is in running state if the thread scheduler has selected it. So let's say you have a run method, you have a start method, so you call the start method. Now thread scheduler has now given the instruction to run the thread. That state we call it as a running state. Now blocked means this is a state where thread is still live but currently not eligible to run. It's got blocked because of some reason your task is not working, your thread is blocked. It is alive, it's not dead, it is alive but not eligible to run. We call it as a blocked. And terminated, a thread is in terminated or dead state when its run method exit. Like now run method is over, now your start method invoked run method execution is over, then we call it as a terminated. So what is the life cycle? New, runnable, running, non-runnable and terminated. And this you can understand by diagram also. New, runnable, running, terminated. Now from running it can go to blocked also. Okay, from running, let's say thread is running, because of some reason got blocked, and again this block can go to runnable. So again block will get will go to the runnable and again your thread will start running. So this is the life cycle you need to just remember. In next topic I will talk about how to create a threads and what are the ways we can create the threads. And this video was mainly to the introduction of multi-threading and multiprocessing. Thank you guys, thank you for watching this.